So hello everyone. I just start. Yeah, hello everyone. Yeah, welcome to join our CASPA Spring Symposium press conference here. So we have people from CASPA team. We have I'm glad we have our chairman and the president, Charlie Zhou. Hao Hua. You could say hi.
Yeah.
Yeah, and we also have several BOD members here. Yan and William and Danny and Mingyu.
Hello, everyone.
Yeah.
Good to see you. Thanks, Amy.
Yeah. And I think we also have our IT support. Mark is always support here for our Zoom meeting. And myself is coming from CASPA media team. I'm pretty happy to be here today. So in terms of we have our honored speakers here. So for Rob,
Hello, everyone.
Yeah. And also we have Michael.
Hello, how are you?
Yeah, good. How are you? Yeah. Also we have several media friends here. So one is KTSF 26. I couldn't. You are mute. Can you say hi to everybody?
Hello. Hi, this is Joe, KTSF Channel 26.
Hi, how are you?
Welcome, Joe.
Hi.
Yeah.
Hey, Joe. Yeah.
Yeah, always see you on the TV.
Good to see. Yeah, we also have David from Singdao Daily. David here. David, you are mute.
Hi, David Wen from Xindao Daily News.
Yeah, welcome. And we also have the Leo from the World Journal.
Hi everyone, Leo from World Journal. I'm new here, so yeah. So everything it's come from is new, yeah. So tell me more everything. Thank you.
Okay, I think I pretty introduced everybody here, so let's start. So basically our schedule will be like we have some brief introduction from CASPA side, like our president Charlie and Yan maybe introduce CASPA and our spring symposium. And then our honor speakers, can you share something about your topic, all those things? Then later on, we will have some Q&A sessions with media friends here. So yeah, let's start from Charlie. You want?
Yeah. Welcome. Yeah. Okay, welcome. Yeah, you can see my slide background, right? It's all the sponsors. So on behalf of the sponsors and 7,000 members, welcome to join our annual Spring Symposium, right? It's like an annual event. Every year we do this. And so CASPA is a tradition focus on the pick the right time and the right topic and right speaker to present the technology related with semiconductor industry for our members and sponsors and also for the industry. So welcome.
Yeah, thank you, Charlie. Yeah, so Yan.
Yeah, I'm Yan. I'm the head of Symposium for this year. Yes, Spring Symposium is one of the big events, major events of CASPA. We have this year. We are focusing on our topic is on the megatrends of semiconductor ecosystem. So we have a list of good, very good speakers, great speakers from all over the companies, and two of them are here today. So we'd like to invite our speakers to have some communication with our media to share your thoughts, and so media can ask their questions and can briefly share your vision and what you think you will cover in the symposium. Thank you.
Yeah, great. Thank you, Yan. So in terms of our honor speakers, so who will start first? Rob?
Oh, sure, I'd be happy to introduce myself.
Yeah.
So I'm Rob Maines. I'm the general manager of CHIPS Alliance, which is part of the Linux Foundation. And the Linux Foundation in general is championing open source collaborative development. And that covers a broad spectrum of different areas, hardware being one of them, RISC-V and Open Power also are participants in that. My talk's going to look at the changing ecosystem of how industry is evolving from what's been done in the past. I think in many ways, I have a long career for those of you that may know me or have heard of me or look at my LinkedIn profile. But, in years past, much of the work was done within one company, a large silo. So if you think of some of the automobile manufacturers, particularly in the United States from years back, 100 years I'm talking or more, everything was done in-house from the motors, the tires, the body of the car, et cetera, right? And that also was true of some of the larger computer manufacturing companies too. And what we're seeing now is that whole ecosystem has migrated to more of just-in-time type of development, which has many different suppliers, but even more so now, more collaborative. And I think a more collaborative effort is required on different technical topics because one of the complexity, but also the fact that companies just cannot undertake the entire R&D investment required for that. So open source is a disruptive initiative that's occurring in the chip development industry to help spawn that further forward. And I think we are just starting to see the beginnings of this in many ways. Of course, there's still going to be proprietary IP involved, particularly for like modern silicon process nodes, but there are ways to allow for different participation to occur through such things as umbrella NDAs. So I look forward to the opportunity to chat and to get thoughts from folks as to how they see this moving forward. And I think we're in for some exciting times here. Thank you.
Yeah, Rob. Yeah, so you're talking about actually you have worked for many companies, right? Before.
Yes, correct.
Yeah, so majority topic for this symposium is like the related to the RISC-V or this open source things.
Correct.
Well,
so in general, the view is that it's one way to look at it is having many eyes on a problem, if you will result in a better solution. So by having people looking at problems from different perspectives, that will result in more robust solutions to that. So that's in part some of the idea of what open source is about. And I do dialogue pretty regularly both with folks at Open Power and RISC-V as example, right? And we chat about different problems, right? And how to help move the industry forward. So that's something, that entire approach is very different, say, than from, benefiting from improvements in Moore's law, if you will, in terms of additional advances in semiconductor technology, or say in packaging technology, or what you would see historically, under one roof of one company, right? So it really is kind of a different approach to solving problems and helping to disrupt or accelerate the industry.
Oh, okay. So our medium friends are our building members. Any questions to Rob you want to talk about?
I do like questions.
Yeah, just ask whatever you want to ask here.
Okay, David Wen from Shindao Daily News. Okay, you're talking about the solution, excuse me, solution and the design. what about the manufacturer? Because the China right now has got a lot of lithographic semiconductor, 光刻机. So is this affect the future of the chip design? Will be go to China or stay in the Silicon Valley?
Well, are you referring to the actual design of chips themselves, or are you referring to the manufacturing of them, or both?
The both. Well, it's like if the China has this capability to catch up the manufacture of the semiconductor, is that will affect the future design of the semiconductor transfer from the Silicon Valley to the China? So that's a question.
I think in general, what we are trying to espouse is global collaboration. So I regularly spend my days talking to people in Europe, in the United States, and in Asia, right? So it's really what we're talking about is, global collaboration. Now, of course, there's always going to be IP sensitivities around that, right? So, as I think everyone in the meeting here knows, that semiconductor manufacturers, for example, spend billions of dollars in terms of developing process nodes and the foundries to support that. So there's always going to be aspects that are protected. I think part of the trick is going to be to, parts that you want to keep secret as to how to obfuscate that, but yet still provide parts of it that are open source to enable collaboration. So I think what you're going to see is more global participation as opposed to regional or national participation by one country. It's just too big of a problem. That's the challenge.
Thank you.
Other questions?
So maybe I have a question. So how do you feel like, so recently we all talking about the shortage of the chips and also shortage of the talented peoples. The job market is super hard now. So what's your insight in it? So can you share your thoughts here?
Sure. So first on the shortage of semiconductors, it's interesting. I don't think any of us quite realize the prevalence and impact of semiconductors in our lives. I mean, certainly, we're obviously all on computational devices right now calling into this meeting, so that's understood. But I think even more simple things such as like a garage door opener or your toaster oven, they all have semiconductors in them. Yes, it's not a 3 nanometer process node, but it is a semiconductor, and that does require engineering talent. So there definitely is still an increasing need for fabrication facilities throughout the world to help meet this need, and across a spectrum of process technology nodes, the older nodes to the newer nodes. It just depends upon what the end market application is, what you're trying to do. Relative to the engineering talent pool, that's a real challenge, right? And that comes on a number of fronts. The first off is to have a diverse and encouraging workplace environment to bring in people from all different backgrounds to participate in that. Now, that's one thing. The other aspect, though, is to make engineering in and of itself more approachable, right? So, as folks on this call know, engineering is not, electrical engineering in particular, it's not the easiest field of study, right? It takes many hours of preparation. But there is a lot of effort to make it more approachable for folks, to make it more software-like. And we are working as CHIPS Alliance in conjunction with Google as an example to make it more approachable, right? To make it more software development-like. So in other words, designing a chip using Python, which is effectively a scripting language, right? But to use that to be able to build a chip as opposed to writing something in registered transfer language, RTL. So I think the comparison is this, that years back when I started my career, engineers were still using punch cards, right? So many people probably don't even know what a punch card is, but it would be a physical card, piece of cardboard that you would type in your instructions, and then it would get read into the computer, right? And so that's where we've come from. Similar, like RTL is like writing an assembler code, right? So we're trying to abstract the problem, bring it up to a higher level, and then also improve the design automation. In other words, the software that translates the design description actually into gates, transistors, if you will, that can then be used for manufacture.
So in your currently like company, do you like feel like it's also still like a challenging thing to hire talented people, and maybe how to keep them stay in the company?
Well, I'm head of an open source group, right? So I don't have anyone working for me directly, but I will say, I was an engineering VP at Oracle, and so I'm very familiar with the challenge of finding talented people and keeping them motivated, and also ensuring that they stay with the company, right? So it is a real problem, right? So it's a combination of different things. I mean, compensation obviously is always important, but I think also providing interesting work opportunities for your employees, providing education opportunities for them to publish, to broaden their overall experience, if you will, professional experience, if you will. And I think it's also just about human relationships, right? It's, like as I've said, I worked in the industry a long time, but I think the best management techniques I learned myself was years back early in IBM, which is also an HP philosophy, Hewlett Packard, that being of management by walking around, which basically is just to stop by somebody's office and just have a chat, right? And, extending now into more modern times, that could be a random Zoom call, a random phone call, just say, hey, how are things going? Just thought I'd chat, right? So something simple like that.
Yeah. Good insight. Yeah. And
I have one more question.
Yeah.
Sure.
Okay.
Go ahead.
The question is, right now, everything is 5G and the Internet of Things. So is this added up to the chip design more complex or more sophisticated and more hard than before? Is that true?
Let me see if I understand the question. So is the question, does 5G itself make chip design more difficult, or?
And plus Internet of Things.
I don't think 5G in and of itself does not make chip design more complicated. I think what 5G is, it's a communication vehicle that opens up additional opportunities. So in other words, you can now say that you build say an IoT device that has a 5G modem on it. Perhaps you license that 5G modem from Qualcomm, right? And that could be like a chiplet type technology, but then that is combined with the IP that your company is developing. And it could also not be necessarily a chiplet. It could be that you license the hard macro that Qualcomm has developed and instantiated, say like in a Samsung or TSMC process technology. And then you put that image on your chip for whatever you're trying to build. So I don't think it makes it necessarily any harder. I think it's more, it opens up additional opportunities. So here's another way to think of it. It's like, I'm sure you can license like a Wi-Fi macro from one of the IP providers like Cadence or Synopsys, right? And you're going to put that on a piece of silicon, and then you're going to put, I don't know, some say machine learning type of accelerator on that. And, you're going to accumulate, well, it could be like a thermostat, right? You just accumulate to observe the temperatures that, the person who's using this likes to have, and then it sets things automatically based upon that. That's just a simple example, but you could easily extend ideas like that to 5G, which basically means that you can put the application anywhere you go, right? It's not limited just to Wi-Fi. So I view 5G as an enabler.
Thank you. Yep.
Quick follow up on the previous exchange. So, hey Rob, this is William Koo.
William.
I reached out to you via LinkedIn, and I'm honored to have. I'll be the MC. I'm honored to have an opportunity to introduce you as our speaker. And I used to, when I was much younger, I used to work at IBM Rochester. I know you were in IBM Austin. Right?
I've been to Rochester many times. Yes.
Right. Likewise, I've been to Austin. So it's feel like although we haven't met, I really look forward to the exchange. So real quick, you mentioned about, potentially using a language, very, how should I say it, easy to learn language like Python, potentially instead of using the traditional languages for RTL. How, and can you say a few words about that? How likely that is going to happen? Because that is really going to make a big difference.
It's all, yeah, so thank you. Yes, and as I recall, Rochester was a big VHDL site, as I recall. So, but anyway, which is Registry Transfer Language Description Vehicle. It's already happening relative to using both Python for design description, and then also Sci5, which is a startup espousing RISC-V technology, is using Chisel. Chisel came out of UC Berkeley, which it's a object-oriented design description language. It's based on Scala. And then, of course, System Verilog is getting quite a bit of interest and use as well. They all have their own specific caveats or interest, if you will. But I think the fact of the matter is that we are looking at a higher level abstraction layer for design description than what we used to do in the past. So it's kind of similar to going from describing things in hexadecimal, right, or octal, originally as I did in my undergraduate, to assembler, to Fortran, to Pascal, to C, to C++, Java, etc. Right. So it's the same type of evolution. But the point is that it makes it, just like, years back when I started my career at IBM, right? So, they had a programming language that you could write. It was higher level, but you could easily go down to assembler, right? But, people don't think that way anymore. Yeah, there's always going to be a necessary few that are going to have to do that, right? And similar to like in the hardware design world, you're going to need people who can actually do analog circuit design, right? To know what that means and all the intricacies involved, right? But in general, what we're trying to do is to make the entire field more approachable for people so that you don't have to be, a PhD in electrical engineering, so to speak.
Well, I wish you the best on that. That really is going to change the landscape and ease the constraint of the talent pool, the engineering talent. Just a quick on a different topic, but related to what you do nowadays with the Chip Alliance. So while I'm not volunteering for CASPA, my day job is with a company called Proteantex. And Michael knows that.
I know Proteantex.
You actually heard of that company? Wow.
Yes, I have. Yes, I like what the technology that you're developing. It looks very interesting.
Right. So a lot of that is putting monitors inside, ever, more complex chips, ASICs, and detect degradations before degradations turn into expensive failures. Is there, I wish, Proteantex solutions can become industry standard, but before we get there, do you and your organization look into something that's related to quality, reliability, near zero DPPN kind of standard that, encourage everybody to follow, especially as we get into autonomous driving, it gets more and more critical that, the failure is no longer an option, right? In some of those, critical applications.
We formulate different interest groups. So short answer to your question is we don't have a specific interest group in that area right now, but there's no reason why there couldn't be. As I shared, I'm aware of the work that Proteantex is doing, and I do find it to be fascinating, and I think it's very timely. I started my career actually in VLSI test and specifically random pattern self-test, so I'm somewhat familiar with that, and also, of course, with different aging failure mechanisms that can occur in silicon over time. And so you're right, in terms of real-time applications like a self-driving car, that's one example, but there are many others. That certainly is a definitive concern that has to be looked at. So the kind of technology that Proteantex is bringing to the table is of real interest. And of course, in terms of helping to standardize that would benefit all as well.
Great. Thanks.
Yeah.
Hi, this is
Yes.
KCSF Channel 26. Rob, do you mind I ask you the question as a consumer and the parents, not a reporter? Is okay?
Sure.
Okay. I want to go back to the chip shortage. My daughter is going to get her driving license. Okay, and then if she got it, she want to buy her car. But we all heard that on the second-hand market, okay, it's more expensive than buying the new car. But if you want to buy a new car, it's out of the stock. So what do you think about the auto industry, okay? And do you think the chip shortage would be solved in the short term, or this is going to be like another couple of years? I think a lot of consumers really care about this question. Yeah.
That's a good question. And I certainly can relate to the challenge about buying a car and, having gone, my son just went through this, so I understand this. Unfortunately, I think it's a long-term problem. And, I work very closely with TSMC, for example, when I was at a VP at Oracle, right? So have had a very good relationship, and they are top-notch in terms of doing forecast planning, et cetera, right? And I don't know, I think it's just a real challenge relative to industry properly understanding or assessing the demands of products. So we had like this glitch or hiccup in demand from like automobile companies, but there are others too, right? That we're all in a collective lockdown for 2 years. And that just caused a huge shortage in production because there just wasn't the demand. So now we have this huge backlog. The problem is that the increased demand from just technical evolution is continuing. So the question is going to be is when can capacity catch up to demand? And I think it's going to be longer than we had anticipated because of just the increased usage, right? I mean, you can see that I'm wearing Apple headphones, right? So it's like a lottery, getting these as an example, right? But it's just because the amount of semiconductor technology present in everything we use all the time has just increased so much. So I think it's going to be a while, a couple of years.
So maybe I would tell her, wait for you go to college. Now she's a junior, 16 years old. She's going to get her license, maybe a couple of years. Thank you so much.
Sure.
Thank you. Thank you.
Yeah, so any other questions to Rob? So maybe we move to the next speaker. So welcome, Michael. So Michael is from the Advantest. So Michael, can you introduce yourself and maybe share with us your topics?
Sure. Hey, my name is Michael Chen. I am the VP and the General Manager at the Advantest Analytic Cloud Solution. And so pretty much that what we'd like to talk about is that in the era of the semiconductor silicon convergence, right? I think how can we using the data mining, the AI, machine learning, right, and doing the gold mining and being able to to enable the better yield and better productivity, right? I think so what I'd like to share pretty much is that as Bob just mentioned there, right, I think we have a pretty good discussion that everybody knows that from this self-driving car, right, from the virtual reality, we talk about this meta universe, right? I think from AI and also to the cloud computing, and we just talk about 5G and IoT, right? So many driving forces pretty much, generally promote the continuous advancement in the semiconductor design, manufacturing, and the test technology, right? So what this means is that there are more and more functionality, right, are being integrated in one silicon, right? I think nowadays you can see that I've been working with those top, either the fabless company or the foundry, right? I mean, they are starting to use this, the 2.5D, 3D technology to integrate more chiplet, right, inside a silicon, right? So the technology is becoming more complicated, right? And there are lots of the steps, right, during the semiconductor fabrication process, right? So the complexity and also the cost, and there's a lot of techniques out there, right, has to be used to continue to be able to improve the yield, right, improving the quality, as well as the being able to reduce the overall semiconductor fabrication cost, right? So how do we do that, right? I think nowadays that people are talking about, I think during the semiconductor fabrication, right? I think generated lots of data, right? People are talking about the total traceability for the silicon manufacturing life cycle, right? Imagine the silicon, from design, the post-silicon validation, from the vapor pour, from the function test, right, all the way to the system level test, and all the process. How do we enable creating people call the production resume, right, for a silicon, right? And how do we actually being able to help collecting the right data, and based on the data, right, being able to analyze, providing the insights, right? I think being able to doing some gold mining, based on those technology. I think those type of technology, you talk about the big data, AI, are fairly popular in many vertical industry, like healthcare, finance, right? I think many other industry. But from the semiconductor fabrication, perspective, right? I think we are seeing that this is, becoming also getting more popular, right? You'll see those leading fabrics, companies out there, right? The foundry, they are generating, hundreds of terabytes of data, right? And for this big amount of those data, right? How can we actually using those AI and analytics, kind of technology, and helping them, right, to improve the yield and bring those technology time to market. So those are a very hot topic nowadays, right? And we are talking about, hey, how can we, leverage those technology and enable those in this the supply chain, right? I think from the upstream, right, talk about from the semiconductor design, right, and combine with the foundry and also the offsets, right? And how can we enable that the complete enable with the right the supply chain with the right the analytics technology. So that's the topics that I will be talking about on March 12th. Is that based on my experience with those semiconductor, the customer experience, right? How can we actually, make the silicon design fabrication time to market, right, and saving the cost. So that's the area that I'll be talking about. Yeah. Yep. Any questions or comments? Yep. Yes.
Everyone from Xindao Daily News.
Yes.
Could you give us a quick comment about the hot topic about metaverse, 元宇宙? Because that sounds like you're going to use a lot of computing power, chips, and network, and everything. So what do you think about metaverse?
Yeah, that's a really good question, right? I think actually I have many, customers actually are working on building the infrastructure for 元宇宙, or you call it the meta universe, right? So you talk about building those the AR, VR goggle, right? All those compute infrastructure, and how do you use those 5G technology to enable the real, like a very virtual reality, very immersive experience, right? And I think all this require a very high performance, compute, right, and high performance communication, and also the graphic processing capability. And to make this happen, right? I mean, in my this is my ongoing experience with those top semiconductor and also a lot of these top company here in the Silicon Valley. So the common things, as I mentioned there, right? All those companies are designing more and more advanced SoC, right? The system on chip, right? And inside this chip, right, you integrate the the RF module, right? The the CPU compute module, right? And the very high performance networking, right? And compute for graphics for that immersion experience. And all this require very advanced, and sophisticated, not just on the silicon design, but also on the manufacturing. Because can you imagine, if you before, right, maybe a couple of years ago, 5 or 10 years ago, one silicon has a one die, but now maybe you have a 5, 10, 20, die in one silicon. So if one die, right, fail out of the 20 in one chip, the silicon yield goes down, right? So how can you actually, during now we talk about the chip shortage, right? So how can you make sure that you control the yield, the quality of each individual, we call it chiplet, right, inside the SoC. So one die, right? Sometimes we call 一锅老鼠屎坏了一锅粥, right? One chiplet fail, then the entire SoC is fail, right? So how do you do the total traceability, right, for all the chiplet, right, during the manufacturing process? How do you control the quality? How do you match the, some of the chiplet, right, is a higher frequency, you have a fast corner, you have a slow corner. How do you match that? How do you enable the quality, right? So that is becoming very complicated, right? And this is a very hot topic. People are starting to think, in order to improve the yield, traceability, and production resume, how can I use this big data, AI, right, to help me to provide intelligent insight, right, into those? That's the hot topic that today, and as we speak, right, I mean, that's every company we talk to, they love to, see, hey, how can you help me, right, to make this happen faster, cheaper, and high quality? Yeah.
Thank you.
Yeah. Hey, Michael.
Hey, William.
Yeah. So good to talk to you again. I think we had a conference call 2-3 weeks ago. Given that you are in a very prominent position from Advantest, I assume as part of your, I haven't seen your slides yet, but I hope that you will talk something about Advantest or ATE in general, none as, but if you may just elaborate a few more words, right? See, this is an opportunity to advertise. How would solutions from companies like Advantest may contribute to what you talk about as far as dig deep into, there's different components within the SoC or different chiplets on the same interposer or substrate?
Right. So actually, William, yes, absolutely. Actually, we actually working very closely with the Polytex, right? I think so for those of the people not familiar with the Advantest, right? So basically, our business focus on the semiconductor testing, equipment, right? And basically, everybody knows the semiconductor manufacturing, right? It's a very asset-heavy investment, right? And to providing the better yield, right, the quality, and reducing the cost, right? So what we're doing is actually we are actually creating a open, solution ecosystem, right? So we talk about that, how to use AI machine learning, right, and a cloud technology to help the semiconductor fabrication, right? So what we're doing is actually we are to make this happen, we are doing two things, right? One is that we are building the semiconductor testing infrastructure, right? I mean, basically providing that the so-called the data highway, right? So being able to providing the test data and equipment data, right? And so to enable the developer in a semiconductor company, the data scientist people, they can do the gold mining based on those data, right? And the secondly is that there's based on the data highway, right? There's a car running on the highway, right? And obviously that the cars, right? I think Politics, right? And Synopsys, PDF, right? We are working with many, the industry leading, the solution provider, and together we are jointly providing those, solution, right? This is what we call it the car, right? Running on the data, the data superhighway. And what we're doing is that, together, right? We are, providing that solution by looking at the different stage of the semiconductor, fabrication process. And the goal is that to provide advanced insight in the manufacturing, testing, and even providing those predictive kind of, analytics kind of capability. Right? I think that's something we are focusing on, and I will be able to provide a lot more details, right? I think, on March 12th. Yeah.
Can't wait.
Yeah.
Can't wait.
Hey, Michael, I have a question. So as you know that last night, the State of the Union speech by Joe Biden, president, he particularly mentioned, introduced actually Pat Gelsinger of the CEO of Intel there, right? And he said that Intel will increase the investment from 20 billion to 100 billion, right? And more to come, he said. So my question is, what do you see this kind of ripple effect will be on the U.S. Manufacturing, the manufacturing chain, supply chain, and also what effect will it be on the silicon, or I would say, semiconductor testing, silicon verification side?
Yeah, that's a really good question. I think the government, right, the commitment, right, to invest and also continue to support the semiconductor, industry, especially from the semiconductor, manufacturing, right, and the testing. I think that is actually a big plus, right, and a big support, for not just the fabless, company, but also from the equipment manufacturer, testing manufacturer like us, right? And then just like you say, right, as you mentioned that we actually are seeing a much greater demands, right? In many states here in this, they are our partners, right? I mean, from those IDM, from those foundry, right? And we are seeing that they are expanding their manufacturing, in Arizona, right? In couple of different states, here in the States here. And from our perspective, right? I mean, definitely that we are definitely excited because from our perspective, we actually are partner, as you speak, right? We are partner with those leading, semiconductor IDM and a foundry, right? And in the process, right, to help them, because you hear from the news, right, there's lots of money, right, gonna be invested in building those the manufacturing equipments, right? And we are definitely part of that, the process. And the things is that if we want to help the U.S. The semiconductor manufacturing industry, here we need to think about it's not just like competing on the chip level, right? Here our end goal is that how can we leverage this AI, machine learning, and some of this cutting edge technology, and providing more advanced insights, right? For both from combine those data from design, manufacturing, and the testing, and being able to continue to improve the yield, right? Improving the quality, right? And that's something that's our focus, right? And as we speak, actually, we are working on some of this, continue a lot of innovation. So probably later this year, we'll be able to, share, what is our plan, right? I mean, working on this innovation, more innovation, right, here in the US. But what you're asking is a good thing, is that the government support is actually is a good thing for us to further, advance the overall efficiency for semiconductor manufacturing here in the US. Yeah.
Thank you. Exciting. More to come.
Yeah, absolutely. Yeah.
Yeah. Any other questions to Michael? It's a very good opportunity. So, Richard Liu, you have any questions for our speaker? I think you are mute, Richard. Yeah, I think actually David previously raised very good questions about the mega world, all those things. So that thing actually, I have a question is maybe pretty similar about the environmental pollution, because that's actually consuming like a lot of electronic and I just wondering any of the speakers could answer this, like how with the semiconductor development, how we protect our environment. So Michael, can you answer my question?
Sure. Yeah, actually, that is a big topic, right? I think one thing, I mean, you'll probably notice, right? I think we talk about those meta universe, right? And you'll be surprised that nowadays, right, with all those the more compute, right? I think from the AI, from the virtual reality, right, from those 5G, the common thing is that with the more the requirements, right? I mean, the demanding, when people look at the better performance, that actually at the expense of the consuming lots of the power, right? Energy, right? And then that has a direct, impact to the, how do you be able to using a more, the green energy, right, to be able to, to supply, right? I think sometimes, that for example, like AI, right? You're using like a deep learning and then to compute something, or using meta universe, right? Their power, right? I think you talk about couple thousand watts, right? In the data center, and then so from the environment perspective, right? I think the industry now need more and more energy, right? In terms of the electricity, and then how do we, being able to, continue to use more solar, energy, right? Or using some green energy, from the wind turbine, or a lot of these things, right? I think that's something is becoming more, critical, especially when nowadays everybody want to have a self-driving car, has a fast AI computing, right? But they didn't realize that the demand for the electricity, right, is a 5x, 10x higher than previously if you don't have those smart device, right? So how can the industry, right, being able to provide using the green energy, right, to meet that requirements, right? I think it's becoming a challenge, right? And we are seeing this is not only, in the States, but also, this is like a worldwide, right? Because when this the advanced SoC, right, power the self-driving AI, 5G, IoT are rolling out to worldwide, right? That electricity requirement becoming huge, and then that actually gonna be having some, driving lots of the power requirement. And then if we are not using the right green energy, right, that could be, a having like a climate right impact, right? So that's the area I see that the industry still need to do a lot of work, right, to catch up, to make sure we have the right green energy policy, and also the planning right in place to supply this surging demand for high power devices in the pipeline.
Thank you, Michael, for all these inputs. Yeah, I think this
Yeah.
is an important topic. Yeah.
Yeah.
So yeah. So I think for the media friends, so we have today is our the press conference. So we will have the symposium on March 12th. So if you need any information or anything, please reach me out. So I'm very glad to provide it. And yeah, please help us to promote this event. I think you already got a lot of information from Rob and Michael here, but we have more speakers and also have panels discussing there. That must be very exciting and get a lot of information there. So please help us to promote the event. Thank you very much. So any other questions so far?
Yeah, I just add a couple words. Can you hear me?
Yeah, please go ahead.
Okay. Yeah. So, there are a couple other speakers not join today, right? Because of the schedule problem. And we will have like ARM and RISC-V and IBM, right? And there was another manufacturer company, executives to present during this symposium. So maybe some media friends are not familiar with RISC-V and ARM, right? It's another CPU architecture against like XPario, right, for Intel and AMD. So that's a bigger ecosystem. So, and IBM, as you know, the semiconductor is an ecosystem, right? It's from manufacturer to the EDA tools, IPs, to the final test, to the system, whole system, right? So the car is a system. So basic idea from the, from product design or from the fab build up, right?
I'm sharing the flyer actually.
Yeah.
Okay, yeah. So that's good. So Ian just showed this one, right? So about the shortage, I just one comment, right? Anything from build a new fab to build a new product, it takes at least 2 years. So you can see anything, start right now is too late. It's really 2 years, right? That's usually the shortage is very hard to resolve. And yeah. So that's just my comments, make sure when you promote, mention other speakers. As you can see, the first one is Microchip and the technical fellow, right? They are focused on RISC-V. And there was Frank Zhou. The second is Michael. Michael is here today, right?
Oh.
Third is Michael Zhou from ARM, IoT department, I think. Yeah. And Robert is here today, right? And Hui Mingbu is from IBM. So I think he major focus on the process side, right? And Richard Yang is our BOE before, and he's in China, and he's one equipment company CTO. So they represent, and William is here too. So just get familiar with these speakers. Yeah, anything Ian can add? I just come to bring up this information.
Yeah, well, I think we had a very good media conference today. Yeah, I don't know if you already have the flyer or not. We'll send it to you, media friends. Yeah, so updated one for you to use it in your promotion or in your ads. Okay. Yeah, I think that's it. Thank you very much for coming, and it's a great one, very informative, and also thank our